Similar shapes have the same angles and their sides are in proportion. By working out the scale factor that links those sides, we can then use that to help us work out other questions that we might be asked. We're going to build upon that skill now to see how we can also find a scale factor that links the areas of two similar shapes and even the volumes of two similar shapes. First of all, let's look at what the scale factor is between the two squares that I've got in front of me. So we've got a 1 centimetre square and a 2 centimetre square. So I think it's fairly straightforward to see that the scale factor between these two is 2. Now let's work out the area of both of these squares. So the area of the first square is 1 by 1, axing there, and the area of the second one is 2 times 2, also not terribly hard. So what we can see is that the scale factor of these areas, I'm going to start to label these differently, so I'm going to put an L to show that that was the scale factor of the length. So the scale factor of the areas of these two is 4. That links to the scale factor of the length, because 4 is 2 squared. So in other words, the scale factor of the area is always equal to the scale factor of the length squared. You can try that out with different numbers. So that's the scale factor of the area and how it links to the scale factor of the length. Now we're going to think about it in terms of volume. So just imagine that these are now becoming cubes here. So what would the volume be of that first cube? The volume would be 1 times 1 times 1. So that's 1 centimetre cubed. And this one, again, turn it into a cube, would be 2 times 2 times 2, which is 8 centimetres cubed. So from that, we can see that the scale factor of the volume between these two shapes is 8. 8 is 2 cubed. So in other words, the scale factor of a volume is the scale factor of the length cubed. So by knowing what the scale factor is between two sides, the lengths of two sides, we can go on to work out what the scale factor should be between the areas of those two similar shapes and the volumes if it's a 3D shape. So let's do a couple of examples. So here we've got two hexagons. We've got the measurements of the sides that correspond, and we've been told that the area of the smaller one is 36 centimetres. So let's start by working out what the scale factor is between these two. So the scale factor of the lengths is going to be 5 divided by 4. Decimal terms is going to be 1.25. Okay, now we want the scale factor of the area so that we can work out the area of the larger size. So the scale factor of the area, remember, is the scale factor of the length squared. So in this case, it's going to be 1.25 squared. So let's bring in the calculator to work that out. So 1.25 squared is 1.5625. So in order to work out the area of the larger one, we're going to take the area of the smaller one and we're going to multiply that by our scale factor for the area, and that will give us the area of the larger one. We've already got the answer from before on there, so we're just going to do answer times 36. And that tells us that the area of the large one is 56.25 centimetres squared. Let's try a volume one now. Got corresponding sides on the cylinders and the lengths of them. and we're told that the volume of the large one is 56 centimetres cubed. So we start by finding the scale factor of the lengths. In this case, it's going to be 5 divided by 2.5, which is going to be a scale factor of 2. To find the scale factor of the volume, we need 2 cubed, which is 8. Now, because we're going from the larger to the smaller, to find the volume of the smaller cylinder, we're going to divide by that scale factor, not multiply. So the volume of the smaller one is going to be 56 divided by 8, which is 7 centimetres cubed.